So hello children, here we are going to discuss about quadrilateral and especially the parallelograms in a better way. I think so concept should rule over the content. You should have a very good understanding about concepts. Alright. So suppose here it is given, suppose in a question they say draw a parallelogram. The children draw different ways, the parallelogram in different ways. Normally a parallelogram should be drawn this way and the figure should speak about the properties of a parallelogram. Alright. Like ABCD is a parallelogram. So if I draw and only two things are very important. Both the pairs of opposite sides are parallel. So AB is parallel to CD and AD is parallel to BC. Secondly, opposite sides are equal. That means if this is 5 meters, this has to be 5 meters. If this is 10 meters, this has to be 10 meters. And this is unequal, so it can be, these two are equal but not, these two are not equal. It may be possible that they may be equal in certain special cases. However, in general cases, both pair of opposite sides are equal. Alright? But adjacent side may or may not be equal. So that is there, and the diagonals they bisect each other. So I would like to first try to clear it with Sachin, that Sachin can come. That some children they draw the parallelogram questions like this. PQRS is a parallelogram. They draw this way. Appears to be right, but you know, what do you say? This is not a very good. That means the child is not having a good concept about it. Why this figure even correct? It is not correct.
Yeah, it is so because this is a special type of a parallelogram. Here we can clearly see that the child has drawn a
rectangle.
Yeah, a rectangle.
Yeah, this is 90 degree. It appears to be 90 degree. Yeah,
it appears to be 90 degree.
Mm-hmm.
So although both the sides are parallel to and equal to each other, but this is a special type of parallelogram because you should all note that all rectangles can be all rectangles are a parallelogram, but all parallelograms cannot be a rectangle.
Oh, that means in general cases they draw, if they are talking, they talk about parallelogram, and if they specifically mention rectangle, then they should draw.
Yeah,
that is what you want to say.
Yeah.
So
square.
Yeah. That's what I was going to ask you. So I think that if you have to say that if a child has drawn square like this in a question, if he's solving a problem in square and he's drawing this like the square like this, normally many children, 99% of children will do this. But what do you say about special children? How do you recognize that a child is special? He has got better concept of square. How do you understand? See, all sides are equal here, but then there is nothing else which is shown. So how do you really describe this?
So I would suggest to draw the square like this. First of all,
that means you want to draw the diagonals first.
Yeah, I'll draw the diagonals first.
So are the diagonals of a square equal?
Yeah.
Okay.
The diagonals of a square are equal.
Okay, and they are what? You are drawing right angles. That means they will be bisecting each other at right angle. Okay.
So the diagonals of a square are always equal.
Okay. Oh, that's great. That sounds better. Yes. Okay, if you could let me explain this to the children. Yeah. Very nice. Okay, now this is perfect. That means AC is equal to BD, isn't it?
Yeah.
That is what you wanted to do. That means the diagonals are bisecting each other. All the bisected parts are equal. This is 10.
Yeah.
And this will be also 10. If AC is 10, BD will be also 10. And secondly, all these are 5. Okay, and then what happens? All these four triangles become congruent. So that means this side, and this side are hypotenuse of congruent right angles. So that means all are equal. It's square. Can we explain? This is also 90 degrees somewhere. Okay.
Yeah.
If this is 90, so these two sum up to 90 and then equal isosceles triangle. So this will be 45.
And this will be 45.
45 as well. So it will be true for everyone. So 45 plus 45, 90. Right. Okay, that means if a child is given this sum, he can better do this one. Okay. Sometimes they tell, okay, Sati, now I got it. So if they tell you, I got this, okay, this is very nice. If they tell that draw a square whose diagonal is 5, now I can know this trick. What I will say, I will draw the diagonal 5, AC I am writing, then I will bisect it at 2.5. Okay, I will bisect it, right. Okay, and then what I will do, I will take this length as 2.5, so I will cut here using the compass, I will cut here using the compass. Okay, I have my square
And then
here.
join.
Okay, so I complete this square. So that's great. So this concept is clear. Okay, and secondly, even if they say the diagonal, if I have got this 2.5, I have got this 2.5, 2.5, 2.5, they can tell me to calculate the side.
Yeah.
So I can use the Pythagoras theorem and I can get this side. I can also get the right. I can also get the area of this by using half base into height, and so this triangle I can get half base into height, and then right, and then I can multiply by 4 to get the whole area.
Yeah.
And what do you say about rhombus? Some children draw the rhombus like this, Sachin. They draw the rhombus. I feel they're right. What do you say? They're right, no? Isn't it? They're right, but there is something missing in their concept or expression. They are expressing it a little different way. Say, for example, from the side sequence.
The square and the rhombus are like very similar to each other, but I would suggest that the best way to draw rhombus is like this.
We can give space to children to see you how you're drawing. I also can see this. Right, I'm coming this way. Okay, sir. Right. Okay, that means that the diagonals are bisecting each other. Diagonals are bisecting each other, right? But they're not equal, it seems.
Yeah.
Okay, so rhombus is different than a square.
Yeah.
Just on one basis here, and that's okay. Got this point. Okay, that means that if this is 10, then this is 5 and 5.
5 and 5. Yeah.
But this is not going to be 10.
Yeah. No.
If it becomes 10, it becomes a square.
Yeah. It becomes a square.
Okay. So that means if this is 10, this is 10, and this is 5, this is 5, and this is, say, for example, 6. So this is 3 and this is 3.
Yeah.
Right. And okay, there are many questions like this where we can get it. Sometimes they say the diagonals of a square are 8 and 6. Find the side.
Yeah.
So if the child draws like this, he will not be able to find the side better. But say they say the diagonals are 8 and 6. Okay, so AC is 8 and BD is 6. Okay, BD is 6. I will draw it a little smaller. And then they are telling to get the sides, right?
Yeah.
So nice. Okay, so this is 8. That means this is 4. And this is 3.
Yeah.
So I can get AB by using Pythagoras theorem. AB is 4 square, that is 16 plus 3 square, that is 9. So 25. So I am getting the side under 25. So how much is the side? Under 25. 5. Perfect. So that is how. Okay. So that means geometry. You want to say that you have to get the concept and the figure should speak. Even a rough figure should be drawn perfectly.
Yeah, perfectly.
So that's great help from your side. Sachin, that's great, and I really appreciate your efforts to inspire children. Anything you want to tell them?
Yeah, I would just like to say that focus on the basics always, because if your basics are right, then everything else will be fine.
Thank you.
Thanks a lot.